I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see the example problem for the algorithm depth limited search. This depth limited search, we are shortly calling it as DLS algorithm. This depth limited search is a search algorithm where the search process is constrained by a specified maximum depth. We have to specify the maximum depth in this. So this is the example problem. Here we have various nodes. So this is the first level and this is the second level, depth 0, depth 1 and depth 2. In this scenario, the depth limit we are setting it as 1, meaning the algorithm will only explore the initial node and its immediate children from here to here. And but will not explore further nodes beyond this level. This can be useful when dealing with the large or infinite spaces where we want to control how far the search will go. The algorithm only explores nodes within a given depth range. At once that range is exceeded, it stops exploring further down the tree. Here, the depth level, this is the depth level, depth 0, and here depth 1. So we are setting it we are setting the depth level for this problem is 1. So first we'll see one by one. First start at node A, that is the step 0. Exploration, this we are calling it as exploration at node A, that is depth 0. This start at node, this is the, we are going to start the algorithm here from here. So start at node A. At the beginning of the search, the algorithm starts at the root node. So this node, we are calling it as the root node A, which is at a depth 0. From this point, the algorithm will attempt to explore its children. But because the depth limit is set to, this is the depth limit, depth is 1, limit is set to 1, it will not explore any node deeper than this level. The first step marks the starting point for the search and no goal has been found yet. The algorithm is ready to explore the immediate children of the node A. So here this is the goal node, but we are setting up for this problem the depth level is 1. Next, we are exploring to the depth 1, that is the children of A, node A, children of node A are. The search now explores the children of node A, which are nodes B, C and D, all at the depth. All these three nodes are at depth level 1. At this level, the search algorithm checks each of these nodes one by one to see if any match, that is any of the nodes matches the goal state. However, since the depth limit is 1, the algorithm will not continue deeper into the tree to explore nodes beyond this level, such as children of B, C and D. So if you are considering B, the children are E and F. For C, the goal node G. So what it will happen? However, since the depth limit is 1, the algorithm will not continue to the deeper into the tree to explore nodes beyond this level, such as the children of nodes B, C and D, that is E, F and G, which are at depth 2. This limits the exploration to just the immediate neighbors of starting node. Next, we are going to meet the stopping criteria. What is the stopping criteria? The stopping the search at depth level, we are going to stop the algorithm at the depth level 1. Once the algorithm explores all nodes at depth 1, in this case B, C and D, it stops because the depth limit of 1 has been reached. No further nodes are explored and the search halts here. The searching will be halting over here. This behavior can be a limitation if the goal is located at a deeper level. As in our example, where the goal node is, where is the goal node? Goal node is at the depth 2. So it is not reaching. Since the search stops after exploring the children of node A, the search misses any further deeper nodes and may fail to find the goal. So what is the final outcome for this? The final outcome is goal not met. So we are writing it as goal is not met, that is not found. In this case, the goal state G is located at depth 2. Since the depth limit is set to 1, the search stops before reaching the goal G. As a result, the goal is not found in the search. If the goal had been located at a depth 1 from over here, it would have been found by algorithm, but in this case, it's missed due to the limitation of the search depth. This outcome demonstrates one of the main drawbacks of using DLS, depth limit search. If the goal lies beyond the specified depth limit, the algorithm won't find it, even if it exceeds in the search space. So what is the disadvantage of using this algorithm is, while DLS can be useful for controlling search space and preventing infinite loops, it has several significant drawbacks. Once the primary disadvantage is that it may fail to find the goal if the goal is located deeper in the search tree than the specified limit. So in our example, where the goal is found, in this example, the goal G was located, that is G is located at depth level 2, but the search was restricted in the depth level 1, causing it to miss the goal. This makes DLS less reliable for the problems where the goal may not be within the search depth. Another disadvantage is that DLS is incomplete if the goal lies beyond the given depth. If the depth limit is set to too low, large portions of the search spaces are never explored, which can lead to an unsuccessful search even if a solution exists beyond the set of depth. Hope all have understood this DLS algorithm. The remaining things we'll discuss in the next lecture. Thank you.